Hi, in this lesson, we'll take a look at recursive sorting. Let's go. We saw in the last lesson that binary searches offered a significantly more efficient way to search through a list of values. However, the list needs to be sorted to execute a binary search. In this lesson, we are going to look at one way to sort an array using a recursive method. In order to utilize our binary search, we need to have a sorted dataset. So the question becomes, how do we sort our data? In Unit 7, we saw an insertion sort. Recall that insertion sorts sort a list by sorting each element compared to the elements already sorted to their left. Selection sorts sort a list by repeatedly finding the minimum value and moving it to the front of the list. In this lesson, we are going to take a look at merge sorts. A merge sort is typically solved recursively, which is why we are looking at it now. A merge sort is a sort where the list is divided, then merged back together in the correct order. This is done recursively, as the list is repeatedly divided in half until it is only one item long. Then each of these lists get combined back together in the correct order. Let's take a look at this graphically. Our merge sort starts at the top with the entire list, then it breaks this list into two halves. Next, it continues this process on one of the halves by breaking it down further. We continue to break it down one by one until we get to individual items. Once one side is broken down, we can then start putting it back together in the correct order. Now we go back to the next section that needs to be broken down and break that into two parts. We then put these two pieces back together. Now that we have two parts sorted, we can combine these two parts and the first half of our list is sorted. We continue the same process on the other half of the data. We break down until we get to individual items, then recombine them in the correct order. Notice as we go through this process that we break down items even if they are already in the correct order. The process is the same regardless of the initial state of our array. We complete the second half by combining the parts. Then our final step is to merge both halves back together in the correct order. Our final result is a sorted array. We can see our merge sort in action on this slide. As it runs through, take notice of how it only works on a portion of the items in the list. You can see how it works on the first half of the data, segment by segment. After completing the first half, the process is repeated on the second half before finally joining the two pieces together. As it joins the two halves, it moves each value from one half or the other into its final sorted place. The merge sort is generally more efficient than our insertion sort or selection sort, and its performance is independent of the initial state of our array. In other words, a random array and a nearly sorted array perform at the same speed. The downside to the merge sort is that the implementation uses a fairly complex recursive algorithm. The implementation usually involves two methods, the merge sort method to break down our array and a helper method to reassemble it in the correct order. In addition, we will look at the runner method. This is the method we will call from our runner class. The main purpose of this method is to break our array into smaller pieces. Then, when it can't go any further, this method calls the merge method to start combining arrays. Using recursion, our base case is when we have only one element in our array. If we are not in our base case, the middle part of this method creates two arrays, a left and a right, and puts half our current array into each of these new arrays. We then make our recursive call with each half of our array. When we get to our base case with an array of size 1, our recursive calls return. We are then ready to combine the left and right array in the correct order. This is accomplished in our merge method. The merge method takes our current array as well as the left and right arrays as input. It will then go through the two arrays to merge them. Notice that it doesn't return anything. This is because the actual array object is passed to the method and updated. Changes can then be read in other methods. The merge method walks through the next element in each array, determining if the left or right array has the smaller value, then inserting it into the current array. Once we finish going through one of our arrays, we may still have elements remaining in either the left or right array. This last step adds any remaining elements to the end of our current array. Our main method creates an array, prints it, then sorts it. We are actually sorting this with a single call to our mergeSort method. In this lesson, we took a close look at mergeSorts. While a complete understanding of the code is not critical, it is important to know that a mergeSort uses a recursive algorithm to sort a list. Now that you've learned about mergeSorts, let's get some practice in the editor.